we will go ahead and get started. Let's see what time it is. So, are there any lingering questions that have been just bothering you over lunch that we want to talk about before we jump into the next section?
You talked about slop containers or slop tanks
Mm-hmm.
in a unit. It means that size exemption
For DOT.
less than 10% water can still for your inspections and monitoring and whatnot.
You talk about the less than 111 gallons? Yes, but it's still got to be, what they're saying there is DOT containers meet BWON requirements. So if you have a DOT container and you're actually operating it and it is closed, like I said, got to make sure operations knows that when you are not dumping something into it, you must, close the lid or the latch. I think more than anything, that's what gets overlooked. Do you have the clicker back there? Because otherwise, with like containers, we haven't gone over the inspection monitoring requirement per each piece of equipment yet, but containers require NDE monitoring. So it's very handy to be able to take that exemption, so you're not out there using Method 21 on drums.
What about just like buckets with a lid? Do you use any size exemption for that?
Well, it's less than it's a less than 111 gallons, and yes. Well, but it's still going to be the DOT.
Yeah.
So.
Because I want to say in like the FAQ, they talk about containers and size exemptions for those too, and we reference that in some of our procedures, but I don't know if it says anything about DOT requirements.
I'm going to look up the citation for you maybe this afternoon and check it out. All right. Anything else? Okay, so Mary Claire went through kind of the control requirements for the different types of waste management units. I'm going to talk now about treatment standards. So for 2BQ in 348, they reference, this is where the treatment standards are referenced. And like I had said earlier, for 6BQ facilities, they are not subject to the treatment standards. So you have options in terms of treatment. The treatment device must remove benzene to a level of 10 ppm without dilution, or you can remove 99% or more of the benzene on a mass basis. The EBU, which is the Enhanced Biodegradation Unit, that is defined in the rule, is an option as well. Other options that you don't see a lot of, I've seen several, deep well injection, RCRA permitted combustion, POTWs, those were all options as well for treatment. So a lot of facilities may not have a full-blown wastewater treatment plant at their facility. They may just have primary treatment, which is the oil water separation portion, and they rely on an off-site POTW or something like that, their bugs and things like that, to do the actual further treatment. Treatment equipment must meet all the BWON requirements, except for, of course, the EBU, which is pretty much open basin type equipment. What that means is, so you have a benzene stripper. Your benzene stripper would fall under the vessel itself. So it's a treatment device, but the vessel itself would fall under one of those waste management unit categories. And for lack of really having vessel type requirements, benzene strippers and other vessels like that are classified as fixed roof tanks, which are typically go through a closed vent system to a control device. So you would look at your benzene stripper and you would have all leak interfaces on your benzene stripper or whatever device that you're using for treatment, and those would all be tagged you don't have to tag, but all of those components would be part of your inspection monitoring program. With treatment, it requires regular monitoring of the treatment device operating parameters. So if you're talking about a stripper and you're trying to meet the 99% mass removal basis, you're sampling before and after. EBU inlets, we'll talk about EBU specifically here in another couple of slides. That EBU inlet stream is another one of the monitoring parameters if that's the option you're choosing for treatment. These are, like we had talked about in the first few slides, these are examples of samples that require you to follow the 355 sampling and testing protocol. And the 6BQ does not require compliance with treatment standards. The only place where 6BQ facilities point back to treatment standards is if their first uncontrolled waste management unit, right, which is the first place which is the place you count for your BQ. If your first uncontrolled waste management unit is an EBU and the concentration entering that EBU is less than 10, then you don't even have to count that stream. So that's the only time that 6BQ facilities reference back. No, it's actually right here. Activated sludge. So what is an EBU? So it's an activated sludge process. Uses a suspended growth process that generates biomass, uses actually recycled biomass, and periodically removes the biomass from the process. So that's the definition in the rule. If the inlet stream, and this is for both 2BQ and 6BQ, if the inlet stream to the EBU is less than 10 ppm, then it's an allowable treatment process for 2BQ facilities. And again, as a 6BQ facility, if it's your first uncontrolled waste management unit and you're less than 10 ppm, then you don't have to count that either. So the rule has typical operating parameters listed. That's your food to microorganism ratio, MLSS, and residence time. This is what your bio units basically have to be designed to meet in order for it to be an EBU under BWON. Now, do you have to monitor these parameters on a regular basis? Anyone? No. There is no requirement in the rule to actually monitor, but if you have documentation that your system is designed to meet these, it's fine. Elizabeth Cannon, who was with Region 6, she kind of made a big deal when she was going around and looking at facilities and wanted them to prove to her via monitoring that they were actually meeting these. But she's no longer there, and I don't think anyone's really heard much in that area since then. Excuse me. All right. How does one determine if your facility's activated sludge plant is an EBU? So again, you have to make sure it's designed to meet that criteria. There's not really, again, explicit requirements to monitor these things, but most of the time, your operating procedures that you have for your bio units, they'll list your MLSS and your feed to microorganism ratio. They'll list all of those things as operating parameters, and as long as those parameters kind of are within the range of what the rule requires, then you're good. Ooh, that's really up there. So treatment standards in the 6BQ. So it doesn't require compliance with 348. There's no reference in 348 or 342E. So given that this is kind of the path for 6BQ facilities back to treatment standards under the EBU. So 342E represents the 6BQ as an alternative to C. And C does not apply to wastewater streams at 6BQ facilities. So therefore, it doesn't go back to 348. It's kind of a big circle. I've had to do this several times to prove to people. So per 355K, and it's also in the preamble as well, the 6BQ is calculated as the sum of benzene quantity in waste streams as they enter the first uncontrolled waste management unit. And again, if that first uncontrolled waste management unit is an EBU and it's less than 10, then that stream, again, does not even have to count toward your uncontrolled 6BQ. So the other treatment options that were mentioned in that one bullet, so the deep well injection, as long as it is permitted under 270 and complies with 122 under 40 CFR. The use of the hazardous waste incinerators, again, they have to meet the requirements listed. And then industrial furnace boiler, we see a lot of these things used as well, injection of the waste stream. The waste stream is treated in accordance with the land disposal restriction under 40 CFR 268, and it's designed and operated with a closed vent system to a control device, meeting 349 in the BWON rule. So, or it can be treated by means or to a level that meets BWON specific effluent limitations under the performance standards under 40 CFR parts 400 through 464. So a lot of this is not, you don't see a whole lot. I've seen two deep well locations in my time with Sage. It's actually pretty, I think they don't have near as much to monitor and look after outside of their deep well requirements under their permit. So, all right. We're now going to revisit the schematic exercise that I tried to jump ahead and do earlier. Now that we have talked about treatment under the rule. Okay, so back to our diagram. So we're still on schematic 2. And so the only thing I changed from the original is I made, instead of this just being a controlled waste management unit, I made this a benzene stripper. And so we already discussed what you do downstream does not affect your tab, right? So your tab is still going to be the A plus B plus C, correct? So now that you've learned a little bit about treatment standards, what would your 2BQ be? Because the benzene stripper is a treatment device. I'm going to write the answer to the first one up here. The first one that we did earlier. Because I like to do the comparison. Not that you'll be able to see it from back there. Okay, so those were the answers for the first one that we did. Yes, you are correct. We are not meeting our treatment device standards in this scenario. So therefore, the 2BQ stays the same under this option. How about 6BQ? Does it change from D plus E? No, because we're still looking at entrance into your first uncontrolled waste management unit, right? So that one stays the same for this scenario as well. And of course, we already said tab's the same for all. All right, so now what if I made, let's go to another color. The concentration of D, what if I made it 2 ppm? So again, tab's the same. Would your 2BQ change now? Right, so what would your 2BQ now be? What's that? E, yes. Your 2BQ for this option equals E. Because you've successfully treated this doesn't count, it's the only thing you have that's uncontrolled coming in, is your groundwater. And it's greater than 10 ppm. Anything for 6BQ? Anything changed here for that? No, it is still the same at D plus E. All right. Now, let's say this is no longer a benzene stripper. It's just a controlled, once again, just a controlled waste management unit. And this is now an EBU. And D, let's say D, sorry, is 12 ppm. What does this change for the 2BQ? So we're going, everything's controlled, of course, except for E, going into an EBU. What does this do with your 2BQ? So going into an EBU, in order for it to be an acceptable treatment device under BWON, it has to be what entering in? Less than 10. And you're talking about each individual, waste stream that is entering that EBU. So we're not meeting that here, right? So we're going to go all the way back again to our point of generation of A plus B plus E for our 2BQ, since we're not meeting the treatment standards. Does everyone see that? Yeah? Okay. And for our 6BQ, anything different there? No, still just D plus E. And our last scenario is if we made D, 5 ppm. So now we're controlled, again, going into your EBU, and we've gotten down to 5 ppm entering the EBU. What would our BQ be in this scenario?
So it doesn't matter if E is, well, E is uncontrolled.
Yeah,
so
E is uncontrolled.
You don't care if it's greater than 10.
Right. So our scenario here would just be E, right? And how about for 6BQ? What is our 6BQ value here? So we're controlled again, entering an EBU. What is our 6BQ? E. It is E because, again, the only time treatment standards apply to 6BQ facilities are if you're entering an EBU and you're less than 10 ppm. It's considered a treatment device. You don't have to count it. So in that scenario, it is E as well. Does everyone get that? Any questions, confusion, kind of around the different scenarios? Okay. All right, so what if your 2BQ facility manages combined wastewater in a controlled wastewater treatment plant en route to an EBU. At one point, maintenance on your DAF forces you to bypass your wastewater through an uncontrolled tank before rerouting it back to the wastewater treatment plant. Is this allowed under TBQ? And how would it affect a 6BQ facility? This is not a very common scenario. And it's one that even I will typically go back and have to refresh myself on when it comes up. So there's something in the rule only for 2BQ facilities called a 1 megagram exemption for aggregated waste. So here's the scenario. So the red is uncontrolled, right? Green is all of your controlled waste management units. And then you have an EBU where typically you're leaving your DAF and going at less than 10 ppm. However, you have an issue to where you are having to bypass and go to an uncontrolled waste management unit, uncontrolled tank. This scenario is allowed for 2BQ facilities as aggregated waste exemption as long as you are still less than 10 ppm in that uncontrolled waste management unit and the total amount of waste that is managed in this tank does not exceed 1 megagram per year of benzene. So that's pretty much what I just said. But it also has a monthly sampling requirement for that stream, just like, you know, it typically would going into an EBU to remain less than 10 ppm. And then again, the total annual benzene quantity in that waste stream, just routing through the uncontrolled waste management unit, cannot exceed over the full year 1 megagram per year. Like I said, it's not very common. It's typically used when you're having to take something in your wastewater treatment plant out of service and you have nothing else to do with it. And you have to route it through an uncontrolled. Well, I would take it in that month. If it was, I would just make sure that you would, for that month, that it was bypassed. I would still, you still have to verify that you meet the 10 ppm coming out of it, going into your EBU. So even if you just did that like initially, you know, if it's only a 2 or 3 week thing, you did that initially, then if you didn't go into the next month, then there's not a requirement for the next sample. So. It does not include waste for which the first uncontrolled waste management unit is an enhanced biodegradation unit. So let's say that you operate a TSDF, which no one here does, which receives benzene-containing carbon waste from refineries and chem plants, and you manage it in containers prior to feeding it to your calcination process, which reconverts it back to into activated carbon. How is the tab accounting for a TSDF different than a chem plant and a refinery? Because all we really talked about is how you come up with tab streams in chem plant refineries. So, you know, in this training, because we don't really have a lot of TSDF people that come. How is it different? And if your TSDF tab is less than 10, are you still subject to BWON control and treatment requirements? Anyone here know how a TSDF calculates their tab? What it's based on? All right, so TSDF calculates your tab based on the waste it is receiving from refineries. So similar to when a refinery or a chem plant is receiving waste from another affected facility, when they're bringing that on for treatment, then that is where their tab starts, is when they're bringing it on site. They may be generating other waste on site as well, but the waste that's coming on site is their tab. So if a TSDF is less than 10 megs a year, that means it's not subject to control and treatment requirements, right? But what if you as a refinery or a chem plant are sending waste that's required to be controlled to a TSDF and they're less than 10 megagrams per year? That means that they have to follow control and treatment standards in order to control and treat your waste per the standards, right? As a TSDF. It's kind of a sticky situation. I believe Ken Gehring, I think it was in 4C, maybe in 2012, TSDFs are kind of a sticking point with them. They haven't gotten a lot of scrutiny from the agency, it doesn't seem like. But he says he knows very few TSDFs that are over 10 megagrams per year. And most people in TSDFs think that they don't have to control anything if they're less than 10 megagrams per year. Under BWON, you are not required to go and audit your TSDF facilities for BWON like you are under RCRA to make sure things are being handled properly, right? The whole cradle to grave. So there's a chance that there's a lot of TSDFs out there that may not be handling your waste that you say requires control as a B1 waste because they don't feel they're subject to the treatment standards since they themselves are not over 10. We've actually come into this scenario several times with clients where they try to send something, they try to explain to them it has to be controlled, and the TSDF tries to tell them, oh, no, it doesn't, because we're not subject because we're not over 10. And we have to work around those issues. And they end up sometimes having to send it somewhere else. And the facilities may be capable of doing it, but a lot of the TSDF facilities, not all of them, but a lot of them do not understand the rule and how it applies to their customers. So it's just something to be aware of. Make sure you call your guys at your TSDF every once in a while and make sure that they understand what you guys need from them. All right, so what if your environmental manager comes to you one day and asks whether you've been inspecting and monitoring the various pieces, or whether you should be inspecting and monitoring the various pieces of your sour water system? So, again, we talked about this morning. Feels like yesterday, but we talked about it this morning. What are your thoughts on that? It's all your above ground piping from your units to your sour water system, the actual tanks and components. If you were to read and go by the ADI that was published, then you would, it says new, I guess it's still relatively new per the, then you would go back and include all of those things into your inspection monitoring program. And in order to demonstrate your sour water system is enclosed, that means all tanks, vessels, flares, whatever is a part of that system, and then whatever's been, and then the control device itself also would come into play. And typically somewhere between point A and point B, that involves your refinery flare. So, and again, like I said earlier this morning, it's really up to the facilities and the companies to kind of take their stance on how they want to handle that ADI. Does anything change if you know some of the waste streams in the system are not truly sour? So if you're treating things in your waste streams in your sour water stripper system that are not truly sour, then those, you pretty much negate the sour water exemption. You have to go back and count all those streams back at point of generation per all the other tab streams. And then, of course, the sour water stripper itself, of course, it may be a treatment device now rather than, it would just be a waste management unit under the previous scenario when you're taking the exemption. And again, it brings in a question of facilities that are not over 10 that operate a sour water stripper that aren't subject to the control and treatment standards and therefore not subject to the inspection and monitoring standards. However, this ADI forces them to do inspection and monitoring anyway. So, any questions on that? Does everyone know kind of how their facilities landed in terms of including that? Of course, it doesn't apply to you, does it? You're not a refinery. And I know you guys are working on it. Are you guys, are they handling it on a case-by-case basis, or?
We're not doing any inspection.
Okay. All right. All right, so why is LDAR important for BWON? The slide's just for you. So BWON contains a lot of LDAR type requirements for monitoring and inspection. So this is your Method 21, no detectable emissions monitoring, which is required annually. We'll talk about consent decree requirements later, which are more stringent, more frequent. So, and we're also talking about only looking at components in vapor service. So BWON inspection and monitoring has been a recent focus during the EPA audits. Every EPA audit in the past 2-3 years involves the use of an IR camera. And they're coming out and using that to determine whether there are leaks in systems, if there's vapors coming up from what's supposed to be water sealed or closed drains, conservation vents, things that really you can't see with the naked eye in a quarterly visual inspection. They're coming and they're hitting facilities up with an IR camera on a lot of their control equipment. And they found also a lot of deficiencies in terms of inventory and equipment integrity too. So your wastewater treatment plants and facilities, typically not the most up-to-date pieces of equipment in the facility, right? Not a whole lot of money has historically been spent on upgrades to those. And a lot of these you'll find that you're continually getting hits on either your annual NDE or your quarterly visual. Every time you go out there, you'll see staining or liquid or something leaking, and no matter how much you fix it, the problem comes back with each monitoring period. So that has been, I mean, there's some pending enforcement right now at a facility regarding a lot of these things right now. They're backing off a little, but not a whole lot. So, other potential LDAR and BWON overlaps. So, carbon canister breakthrough monitoring is typically done by your LDAR contractors on facilities. Waste stream sampling, a lot of times we'll get LDAR contractors to do that kind of stuff, but it's not always them. Junction box sewer vent monitoring and inspection. So, your quarterly visuals. A lot of those guys, and depending on the state, in the state regulations for wastewater too. I know Texas has an industrial wastewater where you actually have to monitor the water sealed drains via Method 21. Closed vent system bypass inspections. Again, that requires your Method 21 monitoring. So how do the BWON components compare to LDAR components? Well, they don't define them the same. So BWON doesn't name a valve, a flange, a pump. It's basically any potential leak interfaces. So if you're looking at a tank, you have manways, you have valves, you have flanges, all of those things, hatches, latches around the, what do you call those little things? They have those explosion-proof lids. Every seam around a controlled waste management unit is a potential leak interface, and therefore all of those things have to be inspected. I had a client recently who's been going back and forth with the agency because they have DAFs, just your regular open top DAF, but they went through and they installed covers years ago to control their DAFs. and their very complicated dome system has kind of like a honeycomb design. They had to go in and add, and there's hundreds of them, every seam on the top of that DAF cover to their inspection and monitoring program. So not just your big seams and your big connectors, every seam on that DAF roof had to be inspected via Method 21. Oh, and it's an oil water separator too under BWON, so that's quarterly monitoring rather than just annual. So it brings any potential leak interfaces in the vapor space to the LDAR program. Questions? You're just angry at me? No. Okay. A lot of people do. I see a lot of people moving to it as a best management practice. It takes I think in a lot of those programs, there's like actually a rule adder, and you can put in your visuals. It makes it super quick to query things. You can start to look at bad actors really easily, like you would under LDAR. So it's a really good tool to use that as the same. I think carbon canisters are the only thing that I've heard people have had issues trying to add into leak dust databases, or familiar or similar type databases.
Just for the visuals, people are putting them in and add on a component by component basis, and some of the technicians will take entire days to do all these visuals when really they can walk down the pipe rack and look at each individual component and press the passes.
Right, you're talking like especially for above ground sewer lines.
Yeah. So I'm just wondering if you guys handle that like component basis, or you just have paper form in an area, say line pass.
Line segment, yeah, that's how I see it most, is a line segment from this vessel to this vessel. The most, I guess, robust one I've seen, they actually had their LDAR contractor go out and put a tag like every 50 yards. And so, of course, some of these you can't reach because they're in pipe racks, but the ones that they could running across the facility, they went through and they tagged it every 50 yards. Obviously not a requirement in the rule, but they were just ensuring that they knew that their LDAR contractor had an understanding of what it was that was, needed to be done. So that's the most extreme I've seen. So again, a lot of non-traditional components that you wouldn't look at or tag in an LDAR program. Typical BWON components that may not be LDAR components, so your drains, manholes, junction box hatches, and roof seams. How are the actual requirements different? So NDE, which is in Method 21, is only required annually under BWON, more frequently under consent decree. The annual requirement is only on components in vapor service. Visual requirements are required quarterly on all the affected equipment. So, and of course you're looking at water seals on drains, which isn't affected by LDAR whatsoever. LDAR closed vent system requires initial Method 21 monitoring on all potential leak interfaces. So that's just your valves and connectors, right? Initially, and then visually inspections annually thereafter. Under BWON, the CVS requires the initial and Method 21 as well as a quarterly visual on top of that. So a lot of the things, some of the components may overlap, and the components that are going to overlap are really only your slop oil organic type components, because most of your wastewater streams are not meeting your LDAR threshold for monitoring, right? In terms of HAPs and such. For inspection, monitoring, and repair, so BWON does not have an applicability threshold for VOC or HAP content. This is what I just talked about. Under BWON, the repair schedule is generally only stated for first attempts, whereas LDAR has a specific first and final attempt mentioned. B1 consent decrees typically increase. This is what I was talking about, the monitoring frequency. So water seal inspections go to monthly, usually under consent decrees. Your wastewater treatment plant, oil water separator, method 21s are typically quarterly under consent decrees. On this whole repair schedule, let's see, do I get to it? I don't think I do. There has been a recent kind of sticking point with one particular region on the whole repair schedule for B1, because there really is no repair schedule listed in the rule for NDE. It's only listed for your quarterly visual inspections. And one region inspector came down, and this is actually part of that enforcement I was talking about earlier, and was attempting to say that if you failed an NDE inspection, that equipment could not be called controlled. And when you're saying something's not controlled, you have to go back, and you're calling it controlled since the last inspection, right? Well, guess when your last inspection is, when you only do it annually. You pretty much potentially put yourself out of compliance for a whole year just by failing an NDE inspection monitoring event. It'd be a little different if it was quarterly, but like with your oil water separators. Obviously, this was fought really hard legal, and Department of Justice finally told the region that this is not a battle that we are prepared to fight. Because if you do look in the rule, and I think there's actually a reference back to GGGA that talks about what the definition of no detectable emissions is, and it's that it cannot leak. There is no repair provisions in the rule for it. But like I said, at the moment, they are not going to continue to pursue that. That's not to say that it may not be pursued at a later date, but right now, Department of Justice doesn't have. I think that they realize industry as a whole. It's very much likely that the majority of facilities would be out of compliance. You would have very few facilities that would be in compliance if they were to push that. What is considered a leak under B1? So the leak threshold, again, for method 21 is 500 ppm for all of the leak interfaces. And again, it's no detectable emissions, NDE. It's different than the LDAR term, no detectable emissions. Visual inspections are focused on tight seals, sealed and latched hatches, covers, presence of cracks and gaps, water seals, and well-maintained gaskets. So if you see a crack in a tank on your visual inspection, or a crack in, say, a concrete junction box, that's a failed QVI inspection, and it has to be repaired. You cannot come and bring your LDAR guy and say, wait, it's not really a leak because it's not over 500 ppm, and say that it's not a leak, because it's still a failed QVI and has to be repaired, caulked, sealed. So you're looking for staining, any kind of presence of liquid or condensation and evaporation. So we actually just touched on this a little bit. So the use of LDAR databases for tagging and tracking inspection and monitoring is definitely a best management practice. You can associate the actual B1 rule to your components under the B1 that you have in the B1 program. Again, you can also use the data loggers and such to manage and upload all of the information. Also document your repairs were completed in a timely fashion or per the rule. You can also use the data logger for carbon canister monitoring. So some of the challenges and recommendations. So for inspection and monitoring, the biggest piece is really understanding your waste management unit inventory. I think that's one of the larger challenges, is making sure that everything that is controlled in your B1 program is actually on your inventory and being inspected and monitored. Some of the best practices, sewer maps. Not a lot of facilities, especially the older facilities, have sewer maps, and if they do, they haven't necessarily been maintained and updated over time. Drawings, kind of an overall drawing of all of your waste management units and where they are at a facility, maybe some mapping tools. And then with wastewater treatment plant equipment, managing the status quo of its wastewater equipment, it's not really a requirement to be. So I'm actually going to pull out, because we haven't talked a whole lot about the specific inspection and monitoring requirements, because there's not a slide on it. Inspection and monitoring requirements for each of the individual waste management units Mary Claire talked about earlier. It is in the resources tab in the back of your book. I think it's like three or four pages back. So fixed roof tanks require an initial and quarterly visual inspection. And they also require the initial and annual no detectable emissions monitoring, so your method 21 monitoring. And the repair timelines are listed there on the far right. So as soon as possible or within 45 days. Typically, your floating roof tanks, you'll just follow KB. That's what most facilities do. Surface impoundments, I don't see a whole lot of those, but if you actually enclosed a surface impoundment and vented it to a control device, then it would require initial and quarterly visual inspections and then your annual NDE inspection as well. Containers, again, initially and quarterly visual and annual NDE. Your closed drain system, that's your IDS. So remember in the rule, the closed drain system is actually a completely closed and vented drain system. And if that is one that you have, it would follow the same requirements of the quarterly visuals and the annual NDE. However, most facilities have water seals using the alternative standards, caps and plugs and such. Those only require the initial and quarterly visual inspections. Unburied sewer lines, so that's your above ground sewer lines. That only requires, that's part of your individual drain system as well. So that would require the quarterly visuals. Fixed roof oil water separators to closed vent system. Those are initially and quarterly visuals and annual NDE. And then the floating roof separators per NSPS QQQ, they follow back on that. So your seal gap inspections, the primary every 5 years, your secondary initially and annually. And then all the covers and openings have to be inspected semi-annually. And when we talked earlier about most floating roof oil water separators do have fixed roof portions, those would fall back on the fixed roof tank, which is quarterly visual and annual NDE. Your treatment processes, initially and quarterly visuals, and then the ones that operate at less than atmospheric pressure, initial and quarterly visuals and annual NDE. And then finally, your closed vent system, those also require quarterly visuals and annual NDE, which when we were talking earlier about the potential of bringing in a refinery flare into an inspection program or as a control device under B1, that brings in a lot of lines in your flare program, so throughout your flare system. Right. If they fall under LDAR, you potentially are, depending on the flare system. Would everyone like to say hi to Larry? This is Larry Darcy. For those that don't know, he's kind of B1 czar for SAGE. He's the president of SAGE, and I guess here checking up on me. Yeah, we were commenting earlier on it would be a very interesting training if it were warm outside, and there were actually people here. So, all right, the wheel of failure. Is this on the?
Pictures.
Okay. see if I can actually pull them up. She doesn't have them on here. Oh wait, I see what you're saying. It's pictures in the slides. We don't have the video though. So we'll just go through the pictures in the slides and not worry about the video. I think a lot of these pictures we got from Ken, didn't we, Claire, that you guys put on here? So Ken Gearing actually provided us pictures from some of his facility inspections that he did over the years. So here is a drain that is supposed to have a water seal on it. It has the BWON tag, and obviously there is no presence of water there in that drain. So this would be a failed inspection. I'm sorry, I keep getting really close to you. Be a failed inspection under your quarterly visuals. I'm not really sure this was associated with inspection and monitoring, but they're sampling that for some reason. Guessing maybe, I don't know if it's an end-of-line sampling, but it doesn't look like it's necessarily being handled in a enclosed manner. Here, I think this is one of Ken's biggest pet peeves, is when he goes out and looks for drains and maybe manholes that say that they've been inspected quarterly for the past several years, but when he goes out and looks for them, they're covered under inches of dirt. Dirt does not suffice as a proper seal around manholes. And that's another thing as well. I'm not sure if we have a picture on here. Debris, dirt in water seals or in P-traps also does not suffice as proper water seal control. A lot of operators, if they're responsible for doing your drain inspections and they see it packed full of dirt, I've heard it and I've seen it, they think, well, it's definitely sealed, it's plugged, and they think that that's okay. The rule calls for a water seal, no other kind of seal in that P-trap. And also oil floating on the top of the water is also not a proper water seal.
Plugged, so the plug has to be rubberized plug? I mean.
Oh, so when you're talking about plug, yes.
Yeah,
So
I mean, the dirt.
So
you say the dirt is a plug?
No.
The rubber is a plug?
No. I don't know how impervious the dirt is as opposed to rubber. So.
Just because that's probably the argument.
Right. Actually see this a lot around oil water separators, lids and latches, a lot of staining, a lot of wetness around seams where there looks like obvious overflow and frequent overflow in these systems. So more than likely, if there is liquid coming out of a leak interface, you can assume that there would be vapors coming out of there as well. So a controlled drain up underneath this blanket, however, we're guessing that it's probably not very controlled if they're actually having to put a blanket on it to keep vapors down. They do this a lot with hot work in areas too, as well, to prevent vapors from flashing up out of the sewer when hot work is going on in a facility. It's a very nice sealed sump or oil water separator. It looks like maybe they recently had some pump maintenance done, but they kind of forgot to put all their bolts back in. They're all stacked really nice and neatly there on top of the lid. Sometimes when you see missing bolts in these systems, if you got a stick or something, you can stick them down there. They may be more superficial and not actually penetrate the actual sump or junction box, but most of the time they do. This is an example of one of those drain inserts that we were talking about earlier. This one is obviously not in place as it's supposed to be, and that happens a lot with the inserts. Operations, they'll need a quick drain to get to drain a piece of equipment, and they'll tube up some tubing into that and remove the insert and not put it back into place. So that would be a failure as well. So, did you want to find take a short break? Because it's not break time yet, right? But we are way ahead of schedule, so. I'm explaining everything too well. Okay.
You need your operating records, so you need dates that you started up, shut down, a description of the parameters that you monitor while you are operating. So any monitoring data that indicates, that didn't sound good. I know, really. Any data that, if you have deviations from normal operating conditions, periods when the unit is not operating as designed, anytime you bypass the control device. So not operating when designed, this could be your temperature, your residence time, anything like that is outside of the design basis. So for each closed vent system and control device, facilities are required to demonstrate compliance, and you can do that 2 ways. You can use engineering calculations or a performance test. And all control devices have to have a statement that's signed and dated by the owner or operating, certifying that that closed vent system and control device is designed to adequately control that waste management unit when it is being vented at the highest load that's expected to occur. So you need documentation signed that your control device does actually control and works and has a design basis. So if engineering calculations are used to determine the control device performance, facilities are required to maintain design documentation, and this could be any type of specific specifications that you have, drawings, schematics, P&IDs. Okay, so now we're going to go into different control devices. A lot of these have the same, kind of like the general same thing, what you need to have in your documentation. We have thermal vapor incinerators, kind of like a thermal oxidizer, catalytic vapor incinerators. With these, basically, you need to know what's going to them. You need to have a composition of your vent stream, the concentrations of those constituents, a flow rate, design minimum and average temperature in the combustion zone, and then a residence time. For this one, if you use some type of catalyst, you need to have just a minimum and average temperature across the catalyst bed for the inlet and outlet. Flares, you need to have a vent stream composition, constituent concentrations, a flow rate, and any other requirements specified in 40 CFR 60.18, whether it's your net heating value, your pilot. Okay, so if you have a boiler or process heater, you need to know what's going to it, your vent stream, the concentrations, flow rates like the other ones, the flame zone temperature is a minimum and an average, combustion zone residence time, and a description of method of where exactly that vent stream is introduced into the flame zone. A condenser, like all the others, you need to know what's going to it, concentrations, flow rate. With this one, you need to know a humidity, temperature, the design outlet organic compound concentration, and or you can do the benzene concentration instead. Average temperature of the vent stream, of the exhaust vent stream, and then average temperatures across the coolant fluid at the inlet and outlet. So then with carbon, we have 2 types of carbon. We have carbon that can self-regenerate, regenerate itself on site, or you have carbon that you ship off-site to like a vendor, Siemens, Calgon, someone. So if you have carbon that regenerates itself on site, along with the first 5 that are pretty standard, you need to have your vent stream organic compound concentration and or benzene. You can do VOCs or benzene. Number and capacity of carbon beds. How many beds do you need? The number, how did you get to that, the design basis. Type and working capacity of activated carbon. And then you need to know stuff about how long it takes to regenerate. Duration of the carbon bed, steaming and cooling and drying cycles. Temperature after regeneration, how long does it take to regenerate, and then the service life of the carbon. So carbon that does not regenerate on site that you have to take off You need to know all of that, and then you need to know what your design carbon replacement interval is. And this is done through engineering calculations or design documentation, design basis, performance testing.
So if you update those, do you have to keep old records also?
No.
Just as long as you have them current?
As long as they're reflective of current operations in that system. Okay, so annual report. Everyone must submit an annual report if you're greater than 1 megagram per year. It's typically submitted on April 7th for the previous calendar year. April 7th is it's kind of a random date, but the rule was first promulgated, I think it was January 7th, so they gave you 90 days. So that's where the April 7th came from. Within that annual report, you have to have your tab waste stream information and estimate, and that was back a few slides ago. We went through the average, the minimum, maximum benzene concentration, flow rates, oil water fraction, things like that. And then a report that summarizes all inspection and monitoring failures and the corrective actions that were taken. If you have to submit quarterly reports, they're normally submitted on a calendar quarterly basis within 30 days of the previous quarter. Within these reports, you have to certify that all inspection and monitoring was completed. And then you report any periods where if you're operating a control device and it was outside of the range of how it's supposed to be operating. So if your flare pilot goes out, your EBU sampling is above 10 ppm, the benzene stripper outlet sampling, if you have any seal gaps on your floating roofs of your oily water separators, and then any seal gaps on your tanks. And that's it for record keeping and reporting.
So we're not calling out a category and you guys are jumping at the question. You will choose the category, you will get the first chance to answer the question. You get it right, you get the points. And then yes, a pass is negative if you chose the question. But if you choose not to steal, then you don't get negative points for not wanting to take a chance at it.
And using your binders.
Oh yeah, gotta close those notebooks. The first day probably is. Good. Oh.
Yeah, this is the essential.
So yeah, the first day we pretty much go over the essentials Jeopardy. Tomorrow's a little harder, and the next day's probably harder. The questions may or may not necessarily be harder as you go up in point value. It's kind of random. So yes, we need to start out with team names. Oh, Laura's, I see it churning.
What kind of improv name do you
I was
have?
thinking we're the B West, like we're the best. The B1, terrible. No. Okay.
What you got, Morgan?
I'm fine with that. Okay, we can be that.
B West?
B West.
Kind of like Kanye.
Yeah.
Oh no. You went there.
Like that? Sure.
Yeah.
Yeah, that's perfect.
To be West.
Do we have to be bees? How does that work?
Yeah, the beast.
All right, we will go ahead and start with you guys. Who wants to pick? Mary Claire sings the music for us. No, just y'all can take turns. For 100.
They said the harder questions can be.
Under the 2BQ compliance option, this is where you account for uncontrolled waste streams. And you are correct. Nice job. What is the point of generation?
Man.
All right. How about you guys? Would you like to select a category?
It would be BWON keeping
For 100? You guys are not very adventurous. This quantity is used to determine applicability to BWON control and treatment requirements.
So,
What is a tab? Is that what you said? That is correct. See, all of those little picks and stuff help. Just tie it all together. All right. West. I'm not sure I'm going to be able to say that as many times in one day. The West. I don't know.
Let's B1 with the B1 and 200.
200. Uh-oh.
Crazy.
These are 2 of the 3 compliance options provided under BWON.
Yeah.
What's that?
What are 2BQ and 6BQ?
Yes, you are correct. What's the third one? Anybody? 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 This isn't for points or negative points. Yes, 1 meg. The one BQ. The 1 meg.
Oh.
The one that no one uses. All right. The Beast.
Weight matters for 500.
500.
Slow down.
Under the 6BQ option, this is the location where you account for uncontrolled waste streams.
What number is it? And with the last week, what is, I think that's what is in the last waste treatment system?
See where you're going, but you gotta say it. All right. You guys want to steal? What? You answered. And it was wrong.
What is the exit of the first uncontrolled waste management?
No. What is the inlet to the first uncontrolled waste management unit? If you combine the 2 of y'all's answers, y'all got it right. So close. All right.
Let's go with control your tab for 400.
Facilities who comply with the 6BQ compliance option, who report a total uncontrolled benzene quantity of greater than this amount, are out of compliance.
What is 6 megagrams?
Yes, that was a toughie, wasn't it?
So, good BWON keeping for 3.
Good B1 keeping for 300. One method of determining waste quantities requires that you use the maximum quantity of waste generated for this period of time. It was like our 5th slide or something. Wasn't very far into it. You have to dig deep for this one.
Yeah. What is the 3-year maximum?
No. Would you guys like to steal?
No.
Anybody? No?
I don't even know.
All right. 5 years. The maximum waste generated over the last 5 years. It was very, very super early in the training. Yeah, that's a different one. Yes. All right. Oh, it's actually listed in the rule that it's you go with design quantities or the maximum waste generated over a 5-year period.
That's for the tab determination.
Yes, that's for your tab quantification for your waste streams.
Let's go with fundamentals for 500.
For 500, and you may be upset at yourself. This is like one of the hardest ones on here. The definition of enhanced biodegradation unit includes typical operating ranges for these 3 parameters. You don't have to know the ranges, you only have to name the parameters associated with it.
What is,
Yeah. Go ahead. You're probably more correct than
what is F to M, the MLSS, and the retention time?
Yes.
Gold star.
It's residence time, but it's the same thing as retention time, so very good.
Oh, you lost connection. No, it's fine.
It's back. I just can't touch the table.
All right, we're tied up.
Wait, I didn't even see. All right, guys, the beasts. Good B1 keeping for 500. This report must include a summary of all B1 inspection and Method 21 monitoring events resulting in failures, including details regarding each failure. Yes, or what is the annual report? That is what the tab report is.
I don't know.
Let's do B1 with the B1 for 400.
B1 with the B1. Under the B1, any junction box requires either a closed vent system to a control device or a vent pipe equipped with this. Time is running out. Okay, answer. You need an answer?
What is a flow indicator?
Yes.
All day over there.
Huh?
You gave them all day over there.
I haven't called time on you guys yet.
Because we've been getting them wrong.
All right.
Control your tab about
Control your tab for 500. This is one of the examples of acceptable BWON control devices under BWON. So you only have to name one.
what is carbon canister?
Yes, that is one. Does anyone want to name any other ones?
Flare?
Yes, that's a flare. So flares, combustion devices, condensers, all types. You're back in the black? Nice.
Just need a bobble over there. Need your time manager to keep up.
B1 fundamentals
For 400.
Oh, that's a hard one.
Under the 2BQ, uncontrolled waste streams that contain less than this are not required to be counted as part of the exempt waste stream list.
Time's up.
10 ppm.
Yes, that is correct.
We're key. We're the BWON.
500, B1 with B1.
B1 with B1 for 500. These two reports are required to be sent periodically to the administrator under B1.
What is the tab in the quarterly report?
Yes. So the annual tab report and the quarterly report.
Big number, damn.
Nice job. You're climbing back up.
Yeah, we went up big numbers.
Let's do waste matters for 400.
For
It's real hard.
400. Waste that are fed back to this are considered to be recycled under B1.
What is the process?
Yes. Process and process B takes. Next, you want the other 400 one? All right, you got to catch up. It is a requirement to monitor parameters associated with the performance of these devices, such as combustion zone temperature for a thermal oxidizer. What are these?
Our B1 control device?
Yes.
Let's do control your tab for 300.
Control your tab for 300. This is one piece of information required to be considered by the carbon canister design analysis per 61356 F2IG.
What is relative humidity?
Yes, that is one of the very, very many buried in there somewhere. It's on the first one on the second line. All right. Next up.
B1 for 300.
These types of waste should be counted toward a facility's 6BQ. Anyone? Time is running out. Yes, uncontrolled waste. It sounded too easy, didn't it? All right.
Let's do B1 fundamentals for.
Is that your favorite category, Laura?
I think it's a funny name.
Under the 6BQ, you must control these types of waste streams and cannot exempt them from control.
Waste less than 10% water.
Yes. Organic waste or waste less than 10% water.
I said it's a
There was an inflection.
I just didn't hear
There
it.
was an inflection of the question, which in many cultures is
Oh no, but yeah, I can't give it to you. I can't give it to him.
No.
But I can't let you guys steal either now that I've. Waste matters for 300. Wrong screen. There we go. This type of waste, it shouldn't be these type of wastes, are allowed to be averaged in the tab calculation, but not the 2BQ or 6BQ.
What are turnaround waste?
Yes.
Getting close. Six of them?
Let's go with control your tab for 200.
Control your tab for 200. These are two examples of controls available for tanks under B1. Two examples. There may be more than two. Need two. Time is running out.
Okay, what are a fixed roof venting to the flare, and that's the first one, and the second one is an internal floating roof?
Yes. Doesn't have to be a flare, but yes.
Yeah.
Yes. That's great.
It's one of the 200. Could be one.
Good B1 keeping. A B1 quarterly report includes a certification that the facility has conducted all of these.
Was inspections and monitoring?
Yes. You are correct.
Let's do B1 fundamentals for 200.
Fencing concentrations used in the calculation of the tab should be averaged in this way. Are we ready?
Minus 200, whether we pass or answer it wrong.
Aw, you gotta try.
Yeah, so we should try, but I don't even know what to try. Maybe that is the
Okay, need an answer.
what is
Pictionary. No.
what is some of the concentration parts of flow rate?
No. No. Minus 200.
We thought so.
Would you guys like to steal? No?
You should try. Believe in yourselves.
Flow weighted annual average. Okay. It is, you guys are up. B East. Waste matters for 200. This is one example of a waste management unit for which the BWON provides control requirements. So you only need to name one. That was nice of me, right? Yes, that is one of them. Does anyone want to name any more? You don't get it. You don't get points or negative points if you just want to throw some out there.
Is a separator one?
Yeah, the oil water separator is one. It's, DAF is considered an oil water separator under B1.
Oh.
A tank is one. Individual drain systems, containers. All right.
Okay. Control your tab for 700.
You're so funny. Divided by 5. If you averaged it over there. This is one of the operations during which it is okay to have open hatches on a B1 controlled container. All right.
What is, when you're adding waste to?
Yes. So you want to say another one or two?
Removing waste.
Removing waste.
Sampling.
Yes, all of those things. B1 with B1? When sampling a waste stream according to the requirements of 40 CFR 61 through 55C3, you must chill the sample to less than this temperature prior to collection.
What is 10 degrees C?
That is correct. And you actually did it in Celsius. I never see it in Celsius.
That's the only thing I see.
All right. Waste matters, huh? Waste matters.
So it really doesn't because it's 20.
Oh, yeah, we can't.
Oh, but we'll do it anyway. According to 40 CFR 35B1, this is the tab accounting location for sour water streams. Where is the tab accounting location for sour water streams? What is that? Is that like a boat?
Where is the exit?
Yes, exit of sour water stream. Nice job.